Hi everyone, this is Neel Raithatha, also known as the Wax Whisperer. Thank you for joining me in my latest video. We have here a patient who attended with a blocked right ear, and as you can see, they've got a very wet, sticky consistency of wax. Earwax can be categorized as either being dry or wet, and the type of earwax that you have is genetically coded. So it's dependent on a single genetic mutation on the ABCC11 gene. If you've got a working version of the ABCC11 gene, which means you must have one dominant guanine allele, it codes for a protein that exists within the ceremunous gland, which is found in the outer third of the ear canal and also under our armpits and in her groin area, that facilitates the transportation of fatty molecules. And these fatty molecules then combine with one another to produce a more viscous, wetter solution that's secreted by the ceremunous glands, which then rises to the surface of the ear canal. So these ceremunous glands are found in the dermis layer, the middle layer of the skin on the cartilaginous portion, the outer third of the ear canal. And these fatty molecules can either be odorous by default, so it's just their chemical composition, they are odorous to begin with, or they become odorous once bacteria that is residing on the skin surface feeds on it. So the bacteria feeds on these fatty secretions, and they then release quite a rancid acidic smell. So the skin itself that lines the ear canal, it has its own ecosystem. You've got bacteria and fungi that live on it, and we call that the skin flora. If you have a non-working version of the ABCC11 gene, it means that it doesn't code for the protein that attracts certain fatty molecules within the ceremunous glands. So the secretion from the ceremunous glands is slightly more viscous, a bit thicker, and therefore it's not as wet. So unless you've been using drops to soften earwax, you either have dry or wet earwax, and that's dependent upon a single genetic mutation. Because these glands are also found under your armpit, that's why sometimes when people exercise, they release a foul odour under the armpits, and that again is whether it's dependent upon whether you've got a functioning ABCC11 gene. If not, the sweat that is produced under your armpits doesn't contain those odorous fatty molecules, so the sweat is not as foul in odour. But if you've got those fatty molecules that are odorous under your armpits, that's why a lot of people suffer from body odour when they exercise. The most of the Western world do. It's, I think, about 70 or 80% of the world's population, and predominantly the Western countries, do have this genetic mutation. You tend to find the dry earwax genetic mutation more in the Far East, also in the North Americas. So it's an interesting fact for you guys. Now, on occasions, I do apologise, it was a bit blurry, and that's just because the entrance of this patient's ear canal is very narrow. I don't know whether you notice, and there's hair sticking out. And I had to get the endoscope almost around those hairs, then into the ear canal to stretch it open. And during that journey, sometimes these hairs, they are naturally coated with oils. So the sebaceous glands, which secretes sebum, which is a fatty, oily secretion. It contains alcohols, squalene, cholesterols, long chains of saturated and unsaturated fatty acids. That all combines into sebum, and the sebaceous glands are connected at the root of the hair strands on the outer third of the ear canal. And so the sebum is transported up the hair follicle, up the hair root, to the external strands that are visible in the ear canal. And sometimes when you go in with the endoscope, and I've actually put some more oil in the ear to help to bind this wax together, which has then coated those hair strands. And when you put the endoscope in, sometimes it just brushes against the lens and it can be a bit blurry. just this last piece. We've removed a tremendous amount of earwax already. The the lateral aspect I removed using a Jobson horn, and the more medial earwax just using suction, and that's a full Zollner suction probe. It just about fits in the patient's ear. Again, just going to go into the ear, move those hairs out of the way. That's the eardrum. The hammer bone slightly vascularis, so it's slightly dilated the blood vessels, and that's just because the wax was impacted up against it. Well, I hope you enjoyed that video, guys. Take care, keep well, and speak soon. Bye.